Right, so we're the Inwerken group. Our sponsor was Bastian Backman and Maxim Reagan, and I'm Andrew Hannaford.
Chris Buzacker.
Nikolai Heiser.
And Taylor Schmidt.
So first off, we're just going to go into kind of who Inwerken are. Inwerken, or Inwerken AG, is headquartered in Hanover, Germany. They're founded in 1999, so they've been around for more than 19 years. And they operate primarily as a consulting development firm, and they are a certified SAP partner. So they are pretty seasoned in the SAP realm, working with big businesses, trying to develop software solutions in Germany and Europe. So Inwerken, kind of like how I touched on earlier, is a professional business-oriented IT consulting firm that makes other people's business work easier. And they do this primarily through SAP solutions, so they modify SAP software to kind of meet the needs of their customers. Another company that is kind of a child company of Inwerken is WSN. And WSN offers hardware and software solutions to capture, transmit, and manage sensor data using Internet of Things or IoT. And they're kind of another piece of this project that we're working with. So it's kind of the hardware and software from WSN and kind of the guidance from Inwerken is kind of where our resources come from in this project.
And moving on to what the need / opportunity is for this project is having the ability for the customer to monitor their warehouse or facility or space that they decide to put this in with the use of different sensors, everything from a Kanban sensor, temperature, humidity, photo sensor, and with the ability to add on to other potential sensors that the customer may want in the future. And why would you ask me? You may want to have a temperature sensor scattered about all over your warehouse. You can collect a variety of data points and say, oh, there's a temperature spike over in the northwest corner of the building. Why is that? Oh, there's a heater going haywire and it's potentially could short out or melt something. Or you have your humidity sensor. Well, there's a big spike of humidity over in this corner and oh, there's a pipe leaking on top of our packages and stuff. Okay, we need to get that fixed. And then our Kanban sensor that we have is up and down switch in a sense that will keep track of the amount of the time, say the shelf is full or the shelf is empty, so that they can get an idea of how long an item's sitting on their shelf or how long it's been empty and that they need to fix a problem in their supply chain of sorts. With that Kanban sensor, it brings in the possibility of the future with automation and having those data times so they understand like how long it would take for, say, like a robot to go and fill that shelf, or how much of a delay they would need in between, and such. And then moving on to our next topic solution.
IoT sensor to monitor data. So what we'd be using the IoT or Internet of Things would be, we'd be setting a bunch of scanners, or not scanners, sensors all around a warehouse. And because of that, we would have the ability to get the data like he had just said. And having quick and easy access to that data will allow us to make faster or more informed decisions on what to do with the warehouse and the things that the sensors are being affected by. Now the sensors are connected to the gateway using LoRaWAN or long-range wireless or long-range wide access network, which allows the sensors to be connected to the gateway from far distances using a low frequency, allowing the distance to be further than normal radio transmissions. And the battery life on the sensors are very long, so you can just put them in the warehouse where you need them and let them sit there for a few years until you're going to need to change them again, which you will be notified by the gateway to do that. Next slide.
And it's nice because a bunch of these sensors, you can add tons of them, and they can all be monitored by a single gateway. So, oh, sorry.
Yeah, so readings are stored in a flexible database. What that means is we will have very large flexibility for different companies to fit their needs. So say one company needed a really bare bones database, they could just get that. Or if another company needed something to be elaborate, they could have that whenever you have a bunch of tables. It also is displayed on a single page application, which would allow just the clicking of buttons. You wouldn't have to go to any external links. You wouldn't have to look around for other things. It's just right there in front of your face. And it would make data collection inexpensive and easy. So instead of having someone go out and actually watch boxes and calculate numbers and spend all that time and possibly even getting hit by one of the forklifts that are driving around, it would be a lot safer and more cost effective for data to be collected this way.
Moving on to the progress that we've made. So to start off with the back end, we have a SQLite database set up. We are using Node-RED, and in Node-RED we've got a flow that will take in these packets from the MQTT broker, which uses a publish and subscribe method, and it takes them from the gateway, and then it also has a flow that will strip this packet. It comes in a large JSON object, and it will take the relevant data from there and save them, so it will be able to update to the database things like the sensor name, the sensor ID, what the date and time of this packet incoming is, and the relative information like humidity, temperature, and whether the shelf is full or empty. So to dive in a little bit deeper on that, we've got our database. So we use SQLite. Why? Because everything for this project is going to reside on this gateway. This gateway is resource limited, both in processing power and in memory. So we need to be conscious of the fact that we don't have unlimited resources with this. So SQL database will be nice and lightweight, and it will also reside itself on the on the gateway. We talked about a flexible database. We have it set up with, instead of boxing into, you can only set this up for rooms and shelves. We have it set up with assets. So if a company, a future customer, has a different type of organization method that they want these sensors in, if they want them on shelves and rooms, they can have it that way. If they want them all to be in a single place, if they have multiple warehouses, it will be simple and intuitive to set up these sensors. To be stored that way without having to worry about creating SQL tables and making the SQL statements themselves. Now, like I said, this is managed through Node-RED. Node-RED is similar to Scratch for IoT. It is a node-based web server, and we are going to give a demo here on a couple of our Node-RED flows. So, okay, this top flow up here, basically what it does, while Node-RED isn't exactly flashy while it's working, it's always going on. So this here connects to the MQTT broker itself. It will subscribe to every sensor that is registered with the network, or with the gateway, and then it takes this packet, converts it into a JSON object, strips out all the information, adds new sensors to the database, and then will update the specific data readings. Down here at the bottom, we are going to have our different HTTP endpoints, so we will be able to pipe this data that comes in up at the top there, and send it to Angular using Angular's HTTP services. This will allow us to get the list of all the sensors, get the list of specific data, readings, so maybe just the humidities or just the temperature, things like that. And in the future, we will also have an update endpoints so that things like the alias of the sensors, their nicknames, can be changed, and things like where they're stored will be able to be modified.
So kind of following up on that progress and status, he talked a lot about the back end and what's going on. I'm going to kind of touch on the front end of what we're doing. So he mentioned earlier we're working with an Angular framework, a single page application, and that's going to kind of enable us to dynamically change a page instead of having multiple different pages that we navigate to using JavaScript. We've made mock-ups of what that page will eventually look like, and we'll touch on that in just a second here. And so we kind of have a direction that we're headed in, and a kind of a design vision that we kind of want to fulfill with our project. So our pages are kind of broken down into these more simple to implement components. Rather than kind of having a really busy page that has a lot of things happening on it, we're trying to make it so it's more simple to look at. When you open a page, you're able to tell kind of intuitively what it's supposed to do and not have to really worry about navigating around or getting lost with too much stuff happening on one space. So I'm going to kind of touch on those mock-ups. So this is kind of what our home will eventually look like. This isn't a live page, but just a mock-up right now. And it's going to kind of have like a high-level overview of what's going on the gateway, kind of through kind of the analytics side. That's going to be like our high-level like sensor data for each different type of sensor. We're going to have the ability to discover new sensors. So kind of if the sensor is not added to the gateway as a recognized sensor, kind of like how Taylor was talking about earlier on that flow, that's going to be the place where you can kind of like make that gateway recognize that sensor as being part of something it should care about and add to the database. Assignment, that's going to be kind of where you can assign the sensors to particular assets. Again, touching on what Taylor said, how you have just having it have asset types rather than having it have a hierarchy in the way that the sensors are organized throughout the gateway's system. You're able to kind of dynamically assign how you want your sensors to be, because I imagine it's going to be different for each facility that you operate. Service and settings are just kind of where you troubleshoot issues, and you might have some advice on how to fix certain problems and maybe some resources and contact information for support services. And so this is our home page. We're going to click over to analytics right now. So this is our humidity page, and how these diagnostic pages work and how humidity's diagnostic page works is you're going to have a graph on one side, and then you're going to have a table of all of your sensors. And so the graph starting out is going to have an average of all the sensor data over time. So you're going to be able to see on a high level what your facility is, operating with, and then these sensors are going to show each of the sensors only one time with its most recent sensor data, where it kicked back and sent a reading to the gateway. And that's going to kind of enable you to not have too much data, kind of what we were talking about earlier, where you're kind of getting overwhelmed with too much sensor data. You only really see the most recent value for each of those readings. And then what you can do is you're going to be able to click on the sensor that you want to see in the table, and it's going to go ahead and it's going to update that graph with data that is for that sensor over time. So you're going to be able to go ahead and narrow down on sensor data for particular areas using that graph instead of trying to use a table, which would be more clumsy. And so some of the information that we're going to see for these humidity sensors, we're going to see the type of sensor, you're going to have an ID, you're going to have the status, which is going to be the reading. So for this one, we have a reading that's for 80% humidity and 72% humidity, so it's pretty wet in this warehouse. It's almost starting to rain. Here we're gonna click over to temperature. So kind of the same story. We have this high-level overview over here on our left, And then we have kind of this breakdown of different sensors. Again, you're going to be able to click into these temperature sensors and kind of see that information over time. So if there was a spike, like last night, for instance, in like where a pipe burst and you got stuff that's cooling down all your facility in a certain area, you'd be able to see that history. And here we're looking at our readings. We got 32 degrees and 25 degrees, so it's pretty cold in there. And then Kanban sensors are kind of more of an abstract idea. Taylor kind of touched on this earlier, and Nikolai did too. But a Kanban sensor, essentially what it is it's a sensor that has a stick on a spring that has a wheel on it. And when the wheel is depressed, Taylor's going to grab it for us. And when the wheel is depressed, it shows that it was, depressed. And using that, we're able to kind of either like do a lot of different process flows. So imagine if this was sitting on a shelf, right? And there's a box on top of it, it's going to be pushed down, right? And that's going to show that the shelf has inventory on it. And then if a box is taken away, it's going to pop back up, and that's going to show the shelf is empty, it needs to be refilled, things like that. Another application could be that you have an assembly line and something passes over it, right? It could go up and down. That could show that when things are moving through it. So there's tons of different applications, so it's kind of hard to make a visual here that is going to be super applicable to a lot of different customers, because that's kind of our goal. So we want to make a product that's going to be on a base level really usable to a lot of different users. So what we decided to do is kind of do what we did for the other project, or the other parts of this, where we had a graph of, well, we don't have the graph, we just have the table of the most recent readings from each of these sensors. And we're going to kind of just click on it, and then eventually we're going to dive down into that data. But this part's still kind of a work in progress at this point, trying to figure out exactly what we want to do with the Kanban sensors. But this is kind of the solution we have so far. It's up for debate, and we're still trying to kind of narrow down on what we want to do. But again, it's kind of difficult because applications from user to user are going to be so different from one another. It's hard to make a solution that really is going to cover all that. So, and then we have photo sensors too, which same thing again, graph, table.
Quick to talk about the issues and risks. The gateway is always listening. It's always receiving packets, or at least trying to receive any packets that are publishing to it. It's important to make sure that we are filtering this data, so non-important data doesn't get published and displayed on our webpage. We've had a few smaller issues with various points, but they've all been overcomable. To talk about risks, kind of on a high level, this is the gateway at its base is running Oracle Linux. These are going to be hooked up to customers' networks. We, in the news daily almost, you see of data breaches. It's important to make sure that this is something we're thinking about from the beginning, because having a Linux box on a company's network with root access can be a pivot point. Attackers can get in from this point, so we want to make sure it's not a weak point in their security. So things that we have had to keep in mind on that is to make sure we are always keeping up to date with the latest patches, making sure there aren't any security flaws in the systems we're running, making sure we have strong passwords and not default ports for any of our ways that we are accessing. And also virtualization. The Node-RED itself is run on a virtual machine within the gateway, adding another layer of security there.
So the schedule so far for Sprint 1, it was January 21st through February 8th. And mainly it was research into MQTT, Angular, and Node-RED. So none of us really had a good grasp on what we were doing, so we took the first sprint to really dig into this research and get more comfortable and well informed about the programming languages and aspects we'd be doing. Sprint 2 was from February 11th to March 1st, and we were developing Node-RED flows, the database schema, the mockup, and the HTTP endpoints. For Sprint 3, it will be between March 18th and April 5th. We will be adding and removing sensors, trying to visualize data, and we will be hosting the page on the gateway.
With our reflections of our previous 2 sprints, we have discovered that working as a group is more intuitive than actually trying to do things individually. Thus, we've made a better point of actually meeting up as a group and making more time for that. Our progress from week to week needs to improve. Thus, we're planning on meeting up more times than later. And we feel like we're not fully grasping or following along with the agile model and documentation as well, which we need to pick up on that.
Okay, so our next steps going forward with our project is kind of like how Nikolai touched on, is going to be kind of to build out our application on our gateway. And we're going to try to make sure that we have a secure method to host the web page, because kind of like how Taylor touched on, if we make an insecure product for Inwerken and they push it out to their customers, they have customers that have very large and high revenue, facilities. If we provide some sort of vulnerability and Inwerken, slaps their name on it, that could be pretty damaging potentially. So we want to make sure that we avoid that risk by addressing it kind of early on. And we're also going to try to connect the database to the application for storing incoming sensor data. So kind of using that HTTP service, we're going to be working with taking that JSON and storing that into our database, our SQL database. And then we're going to also work on adding and removing the sensors, so kind of that discovery and association pages that I kind of touched on earlier. We're going to flesh those out so that way you can really take a sensor and see it, add it to a particular gateway, and then be able to associate it with a particular asset that you want to monitor. So our project was really a challenge, because it's something that we haven't really touched on a lot as a group, but I think it's been some place that we can definitely grow on, because I think that IoT technology is definitely something that's going to only get bigger in the future. Being able to monitor a facility and be able to do particular process flows at scale and on a budget is something that any manufacturer is going to want to do. And so being able to work on this project and being able to develop the skill set and learn about this has been really, really instrumental. And I think that it's allowed us to grow a lot as a group, for sure. Looking forward to the next sprint. So do you guys have any questions for us? Sorry.
So what exactly is Node-RED? It seemed like kind of a framework of some sort.
It's based on Node.js, and it allows drag and drop, kind of like you saw. That's how it all works. You can drag and drop these different nodes that they have in there, and it can do things from hosting web pages to database storage to full-on running JavaScript pages, hosting the pages themselves.
Yeah, you take the nodes and then you organize them together into flows that do particular tasks. And that's kind of what we were showing earlier, is those flows take information from the sensors and kind of flow it into a format that we can use. So.
What's the current status of actually having the Kanban talk and getting status?
So as of right now, that flow will store at any time that's depressed. It won't work right now because it's a little too far from my house, but it updates and stores in the database.
Yeah.
So it stores it. We are just in the process of now getting that information from the database on the gateway to the application on the gateway.
Yeah, we were that Node-RED page was hosted on
I
the.
thought that was working, I just
The
didn't,
gateway.
I was looking for somebody to
Oh.
show it happen.
Yes. Oh no, yeah, we were going to, but we're too far away, so it actually can't pick us up from here. We're going to try to, but
Do you guys have scenarios where you're integrating multiple gateways? Is that within the scope? Or?
that's definitely something we've talked about, and that's kind of where that subscription model of subscribing to certain sensors kind of comes in. So we have it set up right now, so the MQTT broker is subscribing to all topics, and it's just going to pull in everything, and then through SQL, we're going to be able to pick kind of which sensor data the gateway cares about per gateway, because we might have certain gateways that care about, multiple gateways might care about one sensor. So we were trying to make it so it was really flexible, so you could have the sensors be publishing data and have multiple gateways maybe pick it up. Or just have, one sensor per gateway. So make it really flexible, I guess.
Any idea of like having a single view so you can look across multiple gateways?
Multiple gateways? That might be a stretch goal for the future, but I think something we want to kind of try to get figured out first is just having one gateway work with multiple sensors and associate things like that. But
The biggest issue with that would be the data storage between them. Right now, because we're using the SQLite, all of the database files are locally stored on the gateway. So having that would require kind of a database server, not necessarily on a singular gateway.
yeah, because right now all of our software and our databases are hosted on a VM, on a modem, on the gateways. So our storage and our processing power is super duper limited. And we're not able to kind of share that across gateways. So like you said, you'd have to consolidate that. So it would require kind of a separate solution if we wanted to implement something like that.
I guess that would be on a HANA database in SAP.
That seems likely, yeah, probably.
Any other questions?
Thank you.
Thank you.
Thank you.